How do we find some stationary points? First of all, we need to know what a stationary point is, and these are places where the gradient on a curve is zero. So if you remember back to some curves that we've drawn in the past, for example the blue one there, then there are places where the gradient's going up, going down, going up, and there is also places where it's going across the way horizontal. That is where the gradient m is equal to 0. Now there are basically three types of these. They are a maximum turning point, so there's where it's going positive, there's when it's going negative, and there's where it's flat, it's 0. So there's a maximum, then there's also a minimum turning point, so where it's going down, it goes flat, and then goes up again. They're minimum turning points. And then the new ones are called points of inflection. So where your graph goes up, where it goes flat, and then where it goes up again. Or where it comes down, goes flat, and then goes down again. They're called points of inflection. Find them. The process basically involves 5 steps. So the first step is to differentiate. That means you're finding the gradient formula. Second step is where you then say, well, hang on wait a minute, when does it equal 0? When does it actually go flat? So you put that formula equal to 0. If you solve the wee equation that you've just made, that's going to tell you the x coordinate. Then we're going to make something new called a nature table. Now all the nature table is going to do is it's just going to explain whether it's in a maximum turning point, a minimum turning point, or a point of inflection. I'll do an example in a minute. And then you also need to work out the y coordinates. And then you can say that this point is a maximum turning point, a minimum turning point, or a point of inflection. Okay, examples. Find a stationary point or points on y equals x squared plus 4x plus 6. So for stage 1, differentiate. So if I differentiate this, I get 2x plus 4, and then the 6 differentiated disappears. And then the important thing is that we now say for stationary points, or turning points are called, then the gradient, the dy by dx, has to equal 0. Now this stage here is important to include that. Let's move this up a wee bit. Okay, so we know dy by dx has to equal 0. Okay, and we have the dy by dx formula. So the next stage is to put the formula 2x plus 4 equal to 0, which means 2x is negative 4, which means that x is negative 2. Okay, so you've done the first 3 stages. You've differentiated, you've put it equal to 0, and you've solved. Okay, the 4th stage was to do this thing called a nature table. And what a nature table looks like is, draw a table. Okay, the left hand column is, oops, sorry guys, I was on the wrong thing there. The left hand side of the table contains the y by dx. The top line contains your x numbers. Now the x number we found was negative 2. So put that in the middle, and then what we're going to do is we're going to investigate what happens before negative 2 and what happens after negative 2. So pick a number before negative 2, like negative 3, and then plug that back in to your dy by dx formula. And 2 times negative 3 is negative 6. Negative 6 add 4 is negative 2. So you found the gradient was negative 2, which means it slopes down. At negative 2 is 0. It's flat. Now we just need to check what happens as you go past negative 2. So pick a number after negative 2, like say 1. And now substitute that 1 back into your gradient formula. 2 times 1 is 2, add 4 is 6. Positive gradient. So you've got this shape here, so that shape, if you remember back to what we did a few minutes ago, is a minimum turning point. Last thing we need to do is we need to work out the x coordinate, sorry, the y coordinate. If we know that x is -2, then the y coordinate from way back at the start, so you go back up here to your formula, y equals x squared plus 4x plus 6, so -2 squared plus 4 lots of -2, was it plus 6? Hold on till I get a check here, plus 6. Work all that out and you'll find that that comes to be 2, so that tells you that the point -2, 2 is a minimum turning point or a minimum stationary point. Okay, do another wee example for you. So find the stationary points on this curve. Stage 1, differentiate. So dy by dx, 3x squared minus 27. Stage 2, for stationary points, dy by dx must be 0. So put your formula, 3x squared minus 27, put it equal to 0. Solve that. So if I divide by 3, I get x squared minus 9 must be 0. And if I factorise that, difference of squares, I get x is equal to -3, and I get x is equal to +3. Now, two x numbers, right, means that when you come to do your nature table this time, then we're going to do -3 on the top, +3 on the top. So we're going to be looking at numbers getting closer to -3, between -3 and 3, and then after 3. So we get a picture of the shape of the curve. And remember, they're getting substituted into dy by dx. So, pick a number before -3, like -4, and then substitute that -4 back in to your differentiated formula. So 3 times -4 squared is 48, take away 27 is 21, so your graph's going to go up to start with. At -3 is 0, that's what you found, so we can just put that in without doing any calculations. Now between -3 and 3, I'm going to pick 0. It's a nice easy number. And now I'm going to put 0 back in this formula. 3 times 0 squared, take away 27 is -27, so my graph's going down. At 3 it's flat again, so it's going across. And then lastly, pick a number after 3, like 4, substitute that again into the differentiated formula. 3 times 4 squared, take away 27 is 21, so my graph's going to go back up. So I know what it looks like. I know that my graph goes up, down, and then back up again. So to finish the question off, we know the x numbers are -3 and 3. We need to work out the y numbers. How do we do that? We substitute them way back in at the start, so let me find what the start is. Start was y equals x cubed minus 27x, so -3 cubed minus 27 times 3. That is -3 cubed is 27, take away 1 is -54. So the point, that can't be right, guys, is it? Oops, it's take away, it's -3 we're putting in, sorry. So it's -27 add 81, which is +54. So -3, +54 is a maximum turning point. And then substitute in +3, so 3 squared minus 27 times 3, which is -54. So the other one is 3 negative 54, and that's a minimum turning point. Okay, now you can try exercise 14.2.